about it. So let's start with a few words about myself. My name is Anastasia, and I am an engineer from Depop. I am also originally from Ukraine, and yeah, as Adam mentioned, I have two rescued cats, Umberto and Gustav. I couldn't resist to show them. It's my first time speaking at the conference. Super excited and a little bit terrified, so wish me luck. And over the course of my career, I've been working on a few popular products such as Depop, Monzo, and Payment Sense. And A/B testing always been a big part of my job. So today I want to share with you my experience with A/B testing. And to ensure everyone is on the same page, a few words about A/B testing. A/B testing is an experimentation approach that compares different versions of the same app. It tries to measure users' response to version A comparing to version B, and determine which one performs better according to some metrics. It does so by splitting user base into two groups, where group 1 only sees variant A and group 2 only sees variant B. It's also possible to have more than two versions in comparison, and to do so, we would need to split user base into more groups accordingly. A/B testing is not a new word in software engineering, but it really took off when A/B testing infrastructure, tools, and services matured and became more available. On this graph, you can see how the number of A/B tests at Microsoft Bing was relatively slow for a while, and then it exploded when the A/B testing platform allowed to run multiple A/B tests in parallel. So today, A/B testing is an essential tool, and big tech companies run more than 10,000 A/B tests per year. There are many A/B testing services on the market, but the biggest players are Optimizely and Firebase. So today, we will take a critical look at often overlooked engineering challenges and costs of A/B testing. We will see how A/B testing increases code complexity and introduces risks of data corruption. We will explore its impact on testing complexity and debugging complexity. And we will shed some light on developer experience and user satisfaction. Let's start with code complexity. There are many ways of analyzing code complexity. Many of them are quite subjective. But there is one approach that is fairly straightforward and objective. It's called cyclomatic complexity. In simple words, cyclomatic complexity looks at all possible code passes and counts every loop, condition, and so on. For example, instructions following one after another has a complexity of 1. Same function, but with a single if-else statement, has a complexity of 2. And function with 2 if-else conditions has complexity of 3. It's important to know that function with nested if-else statement has complexity of 3. Same works for switch with 3 cases and if-else with 2 conditions. Now let's take a look at the simplest possible A/B test. This code snippet was taken directly from Optimizely documentation. On the first line, we ask Optimizely client to enroll the user into experiment called app redesign. Next, we check if the user was assigned to the variation called control. Control variation usually corresponds to default variation. Next, we check if the user was assigned to the variation called treatment. Treatment variation usually corresponds to default experimental variation. And finally, we check if the user was not enrolled into experiment at all. This can happen if user is not eligible for experiment for whatever reason. In this case, we usually default to control variation. So in this example, we have nested if-else statement. So cyclomatic complexity of this function is 3. But wait, I think we are missing a very important piece here. We are missing final else statement. What should happen if optimizely assigns user to the variation called neither control or treatment? It can happen if there is a discrepancy between experiment setup on the backend and on the client side. Should we ignore this as an impossible state? Or should we fall back to the control variation? I don't think it's a good idea. If optimizely assigns a user to some unexpected variation, but we fall back to the control, it can corrupt experiment statistics. So maybe what we should really do is to crash the app. This would reveal discrepancy quickly and force us to fix it before experiment statistics is corrupted. Anyway, it doesn't really matter which approach we will follow. What is really important is that this conveniently omitted piece of code adds even more complexity to the simplest possible A/B test. The simplest possible A/B test is already pretty complex, but we still can manage it. However, in reality, we seldom run A/B tests on the whole user base. Often, product owners ask us to limit it to some narrow user group. For example, we might want to limit it to a single country to avoid the need of localization. Or it's also common to run experiments that use latest iOS capabilities and APIs. For example, we can compare bar chart with a new pie chart, which requires iOS 17. We can slightly reduce complexity on client side by moving these enrollment conditions to optimizely backend. In this case, these conditions should be passed to optimizely as attributes, and also they will need to be added and maintained to optimizely control panel. While this definitely reduces complexity on the client side, it doesn't reduce testing complexity. The overall complexity stays in the system. We just conveniently put it in another place. Another source of complexity in A/B testing is the need to clean up experiment when it's over. Client-side engineers need to coordinate this process with backend side to clean cutoff point in statistics. Suppose experiment showed that treatment variation is the winner, so we can remove experiment and control variation. We are happily do this and celebrate it with confetti. Now we can admire our clean and simple code, but not so fast. Remember that treatment variation required iOS 17 APIs, but we still support iOS 16. So we must maintain both variants until we are ready to drop iOS 16. Experiment removal can be more challenging than expected. So far, we saw how adding a simple experiment adds complexity to the system. But its impact is seldom limited by only its setup and removal. Often, there will be additional code added to the system to support this experiment. I like to call this phenomenon experiment-induced damage. Here is an example from my experience. Suppose we want to run an experiment where we compare different layouts of the home screen. But we want to account for users who seldom terminate and restart the app. Active users often just minimize the app and return to it later. So we want to ensure that these users will be enrolled into experiment when they minimize and later return to the app. So we observe when app enters foreground and recreate the home screen. We want implementation to be simple and robust. Of course, we could surgically refresh some elements of UI, but the simplest approach would be just recreate home view controller and let it select correct layout based on experiment when it loads views. This code is pretty simple, but yet it adds complexity to the system. And it wouldn't be needed unless we had this experiment. That's why I like to call it experiment-induced damage. Now let's step away from this example for a minute and talk how A/B testing can introduce risks of data corruption and loss. Not all experiments simply compare different variations of UI. Sometimes we want to compare different variations of functionality, or to see if a brand new experimental functionality improves some business metrics. Even payment and subscription models can be A/B tested. Experimental functionality can manipulate user data in a way that is not compatible with existing functionality. And later, if this functionality is removed, user data can be left in a changed state that is hard or impossible to undo. Also, experimental functionality can provide user with a new way of creating content. And later, if this experimental functionality is removed, user can lose access to their new created content. Now let's revisit our example where we recreated home view controller. But now the user is in the process of filling out the checkout form. They minimize the app to copy some information from their notes, return to the app, and the most inconvenient thing happened. The home view controller is recreated, and the checkout form is discarded. It's needless to say that the user is unimpressed. Of course, we can go back to our code and handle this edge case by adding more checks to prevent this bug from happening. But this is yet more code to maintain and to test. Speaking of which, let's talk about testing of A/B testing. We saw how A/B testing increases complexity of our code. Cyclomatic complexity makes a direct impact on testing complexity. The higher cyclomatic complexity is, the more tests in general we need to write to properly exercise our code. To decide how many tests to write, developers often use a metric called code coverage. Code coverage simply marks every line of code that was visited when tests run and reports a percentage of visited lines. For example, we have two completely independent experiments, each with two variations. And to get 100% code coverage, we only need two unit tests. One where both experiments are on, and two where both experiments are off. But to fully understand testing complexity of A/B testing, we need to consider another metric called path coverage. Path coverage measures every code path that was taken when tests run. And in this example, we have 4 combinations of paths. One where both experiments are on, 2 where both experiments are off, 3 where first is on and second is off, and 4 where first is off and second is on. And to get 100% path coverage and to properly exercise all possible combinations of experiments, we need 4 tests. This might look a bit excessive. Why unit tests need to be so exhaustive? Well, consider this example. Path C depends on some state. Path A mutates the state in a way that is implicitly expected by path C, so everything works perfectly. But now we enter path B, which mutates the state in a way that is not expected by path C. So we have a bug. In other words, we have a bug which is present only when 2 experiments integrate with each other. And none of 2 original unit tests would catch this bug. Only integration tests that properly exercise all possible combination of paths could. Of course, if 2 experiments have shared state, we can't call them completely independent. And it's not fair to expect unit tests to catch all the bugs. This wouldn't be a problem if experiments were truly independent. But the problem is that experiments are seldom truly independent, and shared state can be non-obvious. For example, view hierarchy can be a shared state between 2 seemingly unrelated experiments. For example, we have experiment 1, which moves search button from the top of the screen to the tab bar. So variation A, we have search button of the top of the screen, and variation B is being moved to the tab bar. And we have second, completely independent experiment, where we replace tab bar with hamburger menu. So variation C, we still have tab bar, but variation D, it's completely replaced with hamburger menu. Suppose the user is assigned to the variation B and D. Variation D can cause search button to go missing because it replaces tab bar but doesn't account for other ongoing experiments. In the huge team, the left hand often doesn't know what the right hand does. So what advice A/B testing services give us about testing? Optimizely has a list of best practices on what to test. Let's take a look. First, they say that if you try to test all combinations of experiments, you will have explosion of tests. This is exactly what we just saw with path coverage, but yet it was the only way to catch certain categories of bugs. This already sounds concerning. Next, they advise on how to actually write union and integration tests. First, they say that tests needs to be agnostic and unaware of feature flags and A/B tests. This makes sense, but how do we actually do this? They say that we should use mocks and stubs for A/B testing services to force certain experiments to be on and off. This also makes sense, but as I am sure most of you have experience with mocks and stubs, and you know how they add maintenance overhead and even more complexity to the testing. Also, mocks and stubs introduce risks of writing unreliable tests. If mocked behavior significantly deviates from real behavior, it can result into a lot of false positives, which can lead to a false sense of security. And what about end-to-end and manual testing? Optimizely points out that these are the most expensive tests, and that we should reserve them for the most business-critical logic. So it looks like with A/B testing, we almost have no hope to achieve comprehensive and exhaustive testing, both manual and automated. Our best strategy is to choose our battles and to hope that if something bad happens, we can roll back. Hopefully, our QA will catch most business-critical bugs before experiment is launched. Luckily, there is short and easy-to-follow checklist for QAs. So we just established that it's pretty much inevitable that some A/B testing-related bugs will make it to production. So how do we narrow down and debug them? Suppose we start getting crash reports in our issue reporting service like Crashlytics. We can take a look at stack traces to try to narrow down and reproduce the bug. Sometimes stack traces are quite straightforward, so we can easily reproduce and fix the crash. But sometimes they are not so obvious, and additional logs and breadcrumbs are needed to reproduce the sequence of events and the app state before the crash. For apps with a lot of A/B testing, it can be very challenging because there can be hundreds of possible code passes and app states. Crash logs and A/B testing analytics often have separate data streams. For example, you have Optimizely for A/B testing and Crashlytics for crash reports. You might need to maintain additional infrastructure to combine these two data streams together. Mobile clients may need to add A/B testing data as breadcrumbs to crash reports. Also, A/B testing makes customer support harder and FAQ unreliable. Not all bugs result into crashes. Sometimes they stay unnoticed for a while until users start to complain about them. And this is where customer support comes in. Here is a question from Stack Exchange, where one of customer support members complained, quote, "My colleague was unable to follow my instructions. Part of the page I see doesn't exist for them." Users will have similar negative experience with FAQ instructions and screenshots if they don't match the app they see. And this is how I imagine the work of customer support with a lot of A/B testing. We already talked about developer experience of the setup, removal, and maintenance of A/B tests. Now let's talk about developer experience beyond that. When A/B testing becomes highly available, it can result into culture of rapid and aggressive experimentation. We saw on the graphic how the number of A/B tests at Bing went from dozens to hundreds when the A/B testing platform allowed to run multiple A/B tests in parallel. Development teams can get addicted to A/B testing and decide to run every possible change as A/B test first. This can make decision-making on what to build seem easier and the price of mistake, including engineering mistake, seem lower. A/B testing can become a crutch to resolve disagreements on which ideas to implement. And if we cannot agree on which ideas to implement, let's implement all the ideas and roll them out as a quick and dirty experiments and let the data decide who was the better visionary. Rapid A/B testing encourages quick and dirty experimentation because experiments are expected to be short-lived and potentially disposable. This can result into culture of relaxed code review process. So there is a little motivation for developers to take their time and to write high-quality code for their experiments. Often there is a promise to polish or completely rewrite solution if it succeeds in the future. But as we all know, no code is more permanent than the temporary one. Business people are usually experienced in web and think in web terms. They tend to underestimate the complexity of mobile A/B testing. Lifecycle and release management of web application is very different to mobile application. With web page, you can immediately deploy the change, and all users will access it as soon as they refresh the page. With mobile app, there is no guarantee that users will update the app, and multiple app versions exist in production simultaneously. This means that if web experiment has a bug, it can be fixed and redeployed immediately. But if mobile experiment has a bug, the whole A/B test may need to be aborted because there will always be user who didn't update the app and still has the bug, which can corrupt experiment statistics. But perhaps the biggest problem with A/B testing is that most experiments fail. This fact is well documented. AppSummer says that only 1 out of 8 experiments succeed. Google and Microsoft report that only 10 to 20 of their experiments succeed. And other tech companies report similar numbers. Of course, companies don't have any problem with that. After all, A/B testing being one of the biggest drivers of business results ever. For example, this article says that most of your A/B tests will fail, and it's OK. And this article promotes the idea that there are no failed A/B tests. We need to learn how to get value from every failure. And even though I take a critical look at A/B testing today, it's hard to disagree with these articles. The value of A/B testing is huge, and you cannot disagree with this. But developers are humans. We are not cold-blooded or calculated machines or faceless companies. We can try to convince ourselves that seeing most of your work going into trash, it's OK because it benefits the business, but in the long term, it will definitely take a toll on your mental health. I couldn't find a quote, but I remember reading an account from one of engineering managers who spent years working on Facebook timeline, and he said that their developers had very high burnout rate because they made almost no code contribution that survived A/B testing. Facebook timeline was so mature and optimized that it was very hard to land winning experiments. So if you find yourself in a development environment where most of your work goes into trash because of the culture of experimentation, and you start feeling frustrated about it, be careful to not burn out. And finally, let's talk about user experience and satisfaction. If you try to Google random reviews mentioning A/B testing, you will see that most of them are negative, regardless of the product. People always often complain that their People often complain about rapid and unexpected changes, and they are forced to be guinea pigs and beta testers. And some media reporters agree. Yeah, and this is my favorite review. A/B testing may compromise users' preferences and autonomy. Users seldom have any control over experiments they are enrolled into, which is the whole point of random experimentation. Users have different tolerance for change. Premium users with very specific workflows are especially intolerant for unrequested changes. Constant change can lead to trust and reliance issue, especially when the change is frequent. For some users, these changes will look like bugs, and users with special accessibility needs will have a hard time adapting to constant and unexpected changes. Premium users often ask for an option to opt out from all A/B testing. For example, this user got frustrated because Spotify Canvas feature was hidden from them when they were enrolled into experiment, and they lost access to all canvases. For premium users, A/B testing has the same negative effect as seeing advertisements. And this is an example of how open-source Brave browser allows the user to opt out from all A/B testing. However, wording is not very user-friendly. Brave also provides a list of all running experiments and allows their users to see all variants they are assigned to. And also, there is a pull request suggesting more user-friendly toggle to opt out from all A/B testing. Other popular products like GitHub, Discord, and Monzo allow their users to opt out from some experiments. This is great, but an option to opt out from all experiments would be even better. A/B testing tends to be short-sighted, which makes sense, because rapid experimentation focuses on immediate business goals, usually retention rates. But it's easy to lose sight of a long-term effect and overall user experience when considering the result of an experiment. Here is an example of how Facebook ran an experiment where they delivered fewer push notifications to their user, and they see immediate drop of retention rates. However, they decided to carry on experiment for a bit longer, and eventually they saw their retention rate to go up because of overall better user experience. Also, don't forget that A/B testing cannot find taller mountains. You can climb higher and higher on the mountain you're on, but you cannot use A/B testing to find new mountains. If your product really needs a complete revamp, then no amount of A/B testing can save it. True innovation cannot be achieved through A/B testing. We need to start recognizing that there are ethical and unethical A/B testing. As developers, we can start to push our teams to practice ethical A/B testing. Think about user experience, not just conversion rates. Respect users' consent and allow them to opt out. Adhere to data protection regulations, such as GDPR. However, these regulations don't provide a lot of guidance about A/B testing yet. And finally, let's make some conclusions. A/B testing is an essential and powerful tool, and it's not going anywhere time soon. But it's a tool that must be handled responsibly. As software engineers, it's our responsibility to educate stakeholders on costs and complexities of mobile A/B testing. Long-term developer and user experience are equally as important as short-term business outcomes. Cultivate these ideas within your teams. That's all.